Okay, hi everybody. This is the Multi-tenancy Working Group for Kubernetes. It is May 7th, Tuesday, and we have a pretty packed agenda, so we're going to get started. Quick announcement, as you all may have already seen on the mailing list, my co-chair David is stepping down due to having too many commitments and not being able to dedicate the time to being the co-chair. I'm sure he'll continue to be involved in the working group since he's super interested in multi-tenancy. But that means that we are going to open the door for people to nominate themselves to be the co-chair of the multi-tenancy working group. So if that is something you are interested in, please let us know via the mailing list. We are asking that people self-nominate and then attend our next meeting just to say a couple words about why you're interested. And David sent out an email with sort of the whole process based on the working group's docs and everything. So take a look at that. If you're interested, definitely speak up. We'd love to have you on board. And so I think that's the main announcement. The other announcement is that KubeCon EU is in 2 weeks. And at KubeCon EU, we are going to have multiple sessions about multi-tenancy. We're going to have an intro to the working group. We're going to have a deep dive of some of the work that's going on. And we're also going to have a panel with several members talking about multi-tenancy from their perspective. Pretty packed agenda, should be some good stuff. Hopefully we'll have some time to socialize within attendees as well. Looking forward to seeing everyone there. That does mean that we're going to cancel our next working group session since that's the Tuesday of KubeCon EU. So our next meeting will be June 4th, and I will update the calendar to reflect that. So I think that's all the bookkeeping announcements we have for today. Definitely looking forward to seeing everybody who makes it out to KubeCon EU. And if not, the talks will all be recorded and online for everyone to see. And with that, I'm going to hand it over to Yisui, who is going to be going over today the Tenancy CRD work, continuation of the presentation he gave last week, and then Fan Zhang is going to be, Fei Guo. Is Fei Guo on? I'm sorry. Yeah, I see you. Okay, cool, you're on. Fei Guo is going to be going over a proposal for the virtual cluster-based multi-tenancy solution. So handing this over to Yisui to kick off.
Okay, so let me share my screen. Hi everybody, are you able to see my screen?
Yep.
Cool. So first, I have a quick update on the Multi-tenancy repo. I put a links.md file in the docs folder, which collects all the links to the related documents. Because I heard people complain there's too many documents scattered everywhere. So I'm trying my best to put all the links together in a single place. Hope that will help people to find the relevant documents. And for some proposals, if people have any idea or whatever, feel free to send a PR to put an MD file in this folder. Or if you feel better with a Google Doc, you can also do that. Write your own Google Doc and file a PR to add a link in this document that will help people to easily find your document. Okay, now let's move to the tenant CRD. Let's first go to this alternative proposals. So after last meeting, I received a lot of comments and feedback, which are great. And after thinking carefully about the tenant CRD proposal I demoed last meeting, there's definitely a few problems which is not well solved in that proposal. So the biggest problems are I basically list the three items which are the biggest problems. So the first thing is the tenancy CRD we proposed in last meeting will based on a biggest assumption that the tenants are the access of tenants are restricted inside namespaces. So basically, they don't have any right access on any like class scoped policy objects. While sometimes this may be helpful if we allow some tenant users to update some class scoped objects with limited permission, or with some mechanism we can basically verify an individual field inside the object that must comply to some policy defined by the class admin. If we based on assumption the tenants are restricted inside namespace, then we cannot do that easily. And the second problem is about the tenant namespace list, which is a list inside the tenant CRD, and that brings in a lot of problems that people can easily make mistakes with, which will cause a big penalty. For example, if a namespace is then it will automatically delete a namespace, which will cause a lot more impact and expense recovery cost. So the third thing is about extensibility. If in the future, if we want to extend the CRD to contain some more interesting information, we have to extend the schema. That means basically an API change, which is inconvenient for extensions. So based on these three big categories of problems, I came up with some alternative proposals. So here I put up two proposals, and I'd like to hear feedback, or if you have any good ideas, just feel free to raise your thoughts, and I think it's good for you to discuss. So the first one is called tenant administration namespace. So the idea is quite simple. We basically simplify the tenant CRD to basically include almost nothing, probably only a list of tenant admins. And based on creation of tenant CRD, a special namespace is created. Regardless how we name that, we can figure out later how to name that. But a tenant CRD will have a corresponding namespace, and that namespace is called tenant administration namespace. So in that namespace, you can further create additional CRDs for any other purpose. So for example, we promote the tenant namespace structure as a CRD. So within the tenant administration namespace, we create a tenant namespace CRD. It will automatically create a namespace for that tenant. And beyond that, we can also think about other stuff, like probably you can directly create some resource like RBAC or network policy or something that can be automatically applied to the namespace which belong to the tenant. And we do need some help from a webhook, admission webhook, if we want to extend the permission for the tenant user to create some class scope policy objects. Today, there's no quite reasonable use case. Probably security policy is one of them. And to use that, you will have to create something in the namespace which wraps a security policy, and that goes through some automation process, or the class admin may review that. This is not expected. We'd like to have an automated process. Probably we can write some policy to enforce that, to make sure the proposed security policy complies to some restrictions, and that can be created in the class scope. That's one example, maybe not quite good. But that basically gives a lot of flexibility. people can install arbitrary controllers to automate some CRDs, or people can install like per tenant operators to some automated work. And we can also limit the administration namespace to be only used for policy objects. We can use the admission webhook to prevent pod to be created into that namespace, or we can allow that. I'm not sure at this stage. So this is one proposal. The other is using a generic policy engine. So I'm not sure if using a generic policy engine can simplify a lot of work we are doing with a controller plus a admission webhook. Probably that can help us remove or eliminate the need of admission webhook. And with a generic policy engine, it's more powerful to express like a lot of restrictions applied on individual fields of policy objects. That basically makes it easier to allow tenant users to create cluster scope policies, which will be verified by the policy engine to make sure certain fields doesn't violate some predefined policy by the cluster admin. While this is still being investigated, there's a recent open source project called Gatekeeper, which tries to bring in the open policy into Kubernetes. And we are trying to investigate that and try to model some policies which may be helpful for defining a multi-tenant cluster. And there's a Kubernetes policy working group, and we'll probably start a discussion there. And probably we will working on a proposal, try to find out a few policies that can demonstrate some use case in multi-tenancy. So if people are interested, please join this policy working group meetings for more in-depth discussions about this proposal. So I will pause shortly here. If you have any questions or comments, and later I will move to the tenant concept in Kubernetes.
Yisui, so you covered a number of things. Couple of quick comments, mostly applied to the first proposal. One thing to note is that other multi-tenant clusters like OpenStack do not have a tenant administration area. So maybe we need it specifically in Kubernetes because of cluster scope resources or something, but that was just kind of an observation. And also the other point was about the namespace, accidental deletion of the list of namespaces and things like that. Just to understand that carefully, are we talking about the case where when we do an update of a tenant CRD, we forget to include all the namespaces and so it accidentally deletes one of the namespaces? Is that the kind of accidental error you're thinking of?
Yeah, this is one of the mistakes I can think about.
So one of the things I've been thinking about the namespace list itself is, should we even be providing a list of namespace names in a CRD in the tenant CRD to begin with? Because if we are anyway going to go down the line of attaching the tenant name in front of the namespace name, that means that the name that the creator of the CRD provided is not that important anymore because we are making the name unique. So should we think about not even asking for a list of namespace names and just providing the number of namespaces, and then we ourselves name them as, tenant name A, namespace 1, tenant name A, namespace 2. So it's a related but slightly and that then can also mitigate this namespace deletion, accidental deletion thing, because A, you only need to specify the number of namespaces, not their names. And B, we can possibly put in some protection against accidental deletion may or may not need the separate administration namespace.
So the big issue I could see with that, right, is because people are going to put different things in their namespaces within their tenant, and if they needed to delete namespace C, and you have namespace A, B, C, D, and E, how do you handle that? I guess deletion, if you remove it. I really liked Craig's idea last week or last meeting when he mentioned having the namespace be a separate custom resource that is attached to a tenant. So the tenant CRD doesn't have any namespace attached to it. You have to deploy a new tenant that is attached to a tenant CRD.
Yeah,
that
so
abstracts it away, and you have to explicitly delete the tenant CR.
yeah, so originally I was thinking like move the tenant namespace into a separate class scope CRD. And actually, there's a further use case comes up. I think Fei Guo will demonstrate later about Alibaba use case. There's other things similar to tenant namespace CRD. There's more things want to be tied to a tenant. So if we put them all as a class scope CRD, probably fine. I mentioned this administration namespace basically gives tenant admin more flexibility that they can create something in the scope of tenant without a more broad permission on the class scope, because it's really difficult it's really difficult to grant tenant users with certain permission on class scope, but only limited to a set of resources. And that's actually, so the problem is actually, if we grant the permission to the tenant users on a subset of resources by names, the mechanic basically can work, but it's very complicated. And it doesn't have a very good user experience if the tenant users want to create something new, like they want to claim a new namespace. So they probably would need to have create permission of a namespace, a tenant namespace CRD. And so we have experienced that with this controller model. So we will have to plug in the controller will basically populate dynamically the RBAC on the class scope. So I'm not sure that that's acceptable or that will be too complicated.
Just to be clear, just a clarification. When you say tenant administration namespace, you're talking about one additional administrative namespace per tenant, right? So it's kind of like one extra control namespace per tenant.
Yes, yes.
Yeah, okay. Not a global administrator's namespace.
No.
Yeah. So this kind of like several threads here that each need to be kind of discussed here, right? One is the accidental deletion problem, which in my opinion is tied partially to the naming problem as well, which we haven't mentioned. And then there's the cluster scope CRD creation. Would Ingress be another example of a cluster scope CRD that we may want tenants to kind of control?
Probably. Let me think. I don't have a concrete use case in my mind today right now, so I'm not sure I can probably dig deeper and find out some use case. And one other things I remember is I was thinking about the persistent volumes and storage class. I think it's quite reasonable for all these to be managed by cluster admin, but I'm not sure if in some use cases the tenant users will probably need to define some storage class.
Well, storage classes are cluster wide though, aren't they?
Yes.
So I mean,
that can be seen as another thing quite similar to like a port security policy.
right.
We can like automate that by introduce some CRDs into the administration namespace and going through some automation process or review process that finally creates the class scope object.
So I guess, I mean, the one question or one thing that we should take as, I guess, an action is to reach out to, I guess, how the, I don't know, would it be SIG architecture or API machinery maybe, to thoughts that they've had on other people with these issues? Because it can't be the only ones that are trying to put permissions around cluster scoped items, but allow them in certain namespacing. I don't know.
Yeah, so all the class scope resources all facing the same difficulties to have more fine-grained control of permissions for tenant users.
Right. So is there work being done to improve that, or is this basically the lay of the land and we have to base? I guess the question is, do we need to solve this, or is it being worked on and we can basically work in tandem to have an eventual solution that meets our needs?
So I'm going to talk about the tenant concept in Kubernetes, which has some thoughts on that. So I have a feeling like if we rely on existing mechanisms in current Kubernetes, we may come up with a proposal, but it seems like it's like with some sorts of like hacking or patching, whatever. It doesn't come up a very elegant multi-tenancy solution.
Another
yeah, please go ahead.
No, go ahead, complete your thought, please. Go ahead, complete what you were saying, please.
Oh, I'm done. So, I mean,
yeah,
if
one additional comment I wanted to make was, if we do not give any tenant user or admin the ability to create cluster scope resources initially, maybe that's okay. Maybe we defer that as something that only a cluster admin can do on behalf of a tenant. So it may not be as user-friendly as some people might like, but we don't need to create functionality before we truly need it. So we could say that for now, there has to be an interlock between the tenant admin and the cluster admin when the tenant needs a cluster scope resource created on his behalf. I'm just kind of just throwing out a possibility here. And
I think I agree.
Right, and then we wait to see whether the problem is truly necessary before we craft a solution for it.
Yeah, that's a fair point. The only concern I have is so basically we fall to the extendability problem. So we do need some extendability to allow other features to be plugged in with tenant. So without a tenant administration namespace, we are currently defining all other CRDs as a class scope. And I'm not sure that will be difficult in future if we have some other mechanisms to convert all these CRD into namespace scope. That probably would be a problem in future. But I agree, we can stay with a relatively simple mechanism today. When the problem comes up, we can try to solve later. So if no more comments, because I need to be fast, I will switch to the tenant concept in Kubernetes. This document is basically a bit abstract and talking about the thoughts about why we need a tenant concept in Kubernetes and what it helps, and basically how we can figure out a tenant identity in day-to-day like Kubernetes API paths. And I'm not going to go through everything. I just want to highlight a few things. So the first is basically the two ways to define tenant. So it's quite natural to think about when a Kubernetes API server receives a request. If possible, we can derive the tenant ID or tenant name from the user identity. So that means we define a tenant by using a user identity. But actually, that brings in a lot of problems. The biggest one is basically it's ambiguous. Because a single user identity, a single user can belong to multiple tenants. When making an API call without explicitly specifying the tenant name, it will be difficult to figure out which tenant the user represents. And that's also extends to the problem with service counts. Service counts is more like a system level and more neutral to tenants. So when a controller is running, how can you tell which tenants this control represents in terms of a specific API call? So a few ways to work around this. We can introduce a tenant name in the API path as a high-level scope above namespace. Definitely that requires significant change of API server and a lot of complication implied by this. And the alternatives, we can introduce a new HTTP header like X Kubernetes tenant and put the tenant name there, which also requires the tenant must be explicitly specified for every API request call. That doesn't solve the service count problem. When you build a shared controller across all the tenants, it must be aware of tenants and bring in complicated logic to figure out the tenant name for every API call it made. So alternatively, we are thinking about a different angle to represent tenant, because for the API call, every API will have a target resource. So if we associate a tenant on the target resource, regardless of who's making the call, that may simplify the problem, and that can eliminate the ambiguity. So a very simple way, we don't need any change on the Kubernetes. We just put a label on the resource. And for every API call, we figure out a label from targeted resource, and that represents the name of the tenant. For all the namespace scope resources, we just put a label on namespace. Don't need to dig deep into every resource. So that's actually a better way to represent the tenant, to figure out the tenant name for each of the Kubernetes API call. So this is basically two ways to define a tenant. And the last thing I want to mention is, I call it impractical sorts, but I'm not sure it's really impractical or not. So I remember there's a few discussions happened quite long ago about the hierarchical namespace. To solve multi-tenancy, basically hierarchical namespace is a way better solution, which tackles a lot of problems we are difficult to solve today. So first, like naming conflict. With hierarchical namespace, we don't have naming conflict. And the resource visibility, we basically can encapsulate resources within a container, which is like a tenant, without like a single list call will list all the cluster scope resources, regardless which tenant it belongs to. And it's also possible to introduce like a nested tenant, though it's not quite practical to have a very deep nested level of tenants, but usually like a tenant plus a subtenant will be quite common in a lot of use cases. And the last one, it can be quite useful, is for the policy inheritance and override. Today, it's really difficult to do the policy inheritance and override. All the policy objects are either defined as class scope or namespace scope. And there's no overridden between them. While by introducing the hierarchical namespace, the policy defined on higher level or top level of namespace can be inherited, and the lower level namespace can define some overrides. So ideally, if we think of the cluster as a root namespace, basically we don't need any class scope objects. Everything will be namespace scoped. So starting from the top of the cluster is root namespace. And after that, people can feel free to define any structure of namespaces to represent tenants or whatever, tenants inside the tenants. And all the policies can be managed in the same way.
So you see, this is Kurul. Can you hear me?
Yes, please.
Yeah. So in the previous section, right, you were mentioned that the tenant will be represented as a label. If I have a workload, right, for example, a pod, and it has to use the particular CPU or memory, so I have a restriction for my tenant. So how using the labels, I have to derive the namespace as well, right? So currently in the POC, that namespace is derived from the tenant name and the name itself. So how it will be reflected if I have a workload? So how you specify the namespace for that workload based upon the tenant name? How it happens? Do you have an idea on that?
So you are asking, in the POC, we have like tenant name prefix on namespace. So
Yes.
you're asking
So
if we can derive the tenant name from the namespace name?
yeah, for the workload actually. If I have a workload, right, I have to specifically have to say tenant hyphen ns1 or something like that.
Mhm.
So in case if you have a label, right, there should be a mechanism or an admission muting webhook that will get the tenant and the namespace, and it has to insert that specific name space for each pod or the workloads, right? Is that
Yeah.
the mechanism we have to do that?
Yeah, so you're right. So if we are using labels, we do need a admission webhook to protect the label.
Okay.
Because today there's no mechanism to protect a label. Anybody have permission can update the labels. So we do need that. And
So
as you said, yeah, please go ahead.
even to insert that namespace in each pod, right, we should have a mutating webhook which could add the namespace as a patch in each pod spec. Something like that we should have. I'm just going in the implementation, but I just need to get some ideas actually. That's why.
I'm not sure I understand. You need to add namespace to the pod because pod is inside namespace.
Okay. Inside. Okay, I got you. Okay, sorry for that. Okay.
Yeah, so you mentioned that we can probably derive the tenant name from the name of namespace or name of other cluster scopes resource. Probably yes. But I will hesitate to say that because we are still discussing if the name should be always prefixed by a tenant, or we should decouple the name from be linking to a tenant. And actually, using a tenant prefix on names is kind of like similar concept, like a little similar to introduce this hierarchical namespace. If we abstract the namespace using like a pass format, using a slash to split that, basically you can think that tenant name becomes a prefix of namespaces.
Okay, thank you.
Yeah, so I like to dig a little deep about the hierarchical namespace to try to figure out a little more details, how much of effort about this change is it reasonable, or what it brings in to build a multi-tenant model, and probably it's not impractical. So I will have it updated maybe in next working group meeting.
So this is Mayank. I'm a new member here. Are these proposals in KEP form already, or are they being discussed in doc? And is there a list of proposals I can take a look quickly and comment on the doc or somewhere?
So go back to this repo. We have Kubernetes 6 Multi-tenancy Repo. So these docs are already put in this doc with links. So these are draft proposals today. The most recent draft proposal we have. If you want to take a look and comment, just starting from this doc and clicking to the link.
Got it. Cool. And then I didn't understand the part where you talked about, or somebody talked about introducing the tenant in the API server, APIs, or all calls to API. What did that mean specifically?
So there's a few ways to introduce a tenant into natively into Kubernetes. Quite intuitive way is if we think tenants is a layer above namespaces. So today's API server, it has API paths like API/v1/namespaces and whatever namespace name, and then /resource type/resource name. So by introducing a tenant, one possible way is like we change the API paths like API/v1/tenant/tenant name, then /namespaces/namespace name. So that requires significant change on the API server.
Right. Got it. Okay, cool. Thanks. And then does this doc discuss all the other ways of doing tenants? So basically a tenant that so this basically you're saying introduce a concept above namespaces, which can encompass a list of namespaces, right?
Yeah, so one way you can think about tenant as a concept above namespace, or if we use hierarchical namespace, probably we don't need that concept.
Then hierarchical namespaces could be basically either implemented as a label or basically when you say hierarchical, you mean like nesting, right?
Yes.
Okay, so one namespace can be within another namespace.
Yes, so not completely true. We will make it looks like that.
Okay.
So with help of that, the basically the policy objects can be properly aggregated in a hierarchical way. That will help solve a lot of problems.
Got it. And then so one was something on top of namespaces. Second is hierarchical. Third is a list of users, somehow a list of users and service accounts all being clubbed as a tenant.
Yeah, so this is basically the first first the representation of tenants, as I mentioned, as a group of users, which includes users, groups, and service accounts.
Okay. But what will be the concept called? Like, I mean, basically it will be somehow like using a label, club them together, or using a top level object that will basically somehow specify all the users or service accounts that encompass it. I mean, I know I'm asking details that you're probably still thinking. I'm just asking what's the thinking there.
Yeah, so that's where basically the design details or implementation details. There are a few ways. So one way we can have a CRD called tenant and include all these users and groups and service counts. And other ways like labels is also possible, but the labels has other problems that can, I'm not sure maybe the problem. That will be a little difficult to manage. To associate the users, because the user doesn't have an object inside Kubernetes. So you cannot put a label on users.
Right.
So one way to look at it is that really there are two, at a high level, we are kind of talking about two categories of solutions. One is a tenant is a CRD sitting on top of a collection of namespaces and resources, and users are associated with that tenant indirectly, not directly, because as Yisui said, there's no users in Kubernetes. And then the second thing is the hierarchical namespaces. Now, it seems, correct me if I'm wrong, Yisui, but if we do hierarchical namespaces, that's really going back to the API server team and asking them to extend the namespace model itself to create hierarchical namespaces and just handle it that way. And then what we've been in this team sort of talking about and prototyping is more like the concept of a tenant CRD sitting on top of a collection of namespaces.
Yes, that's true. So why I raised the idea about the hierarchical namespace, because I have a feeling building a tenant CRD, we will spend a lot of effort and make things quite complicated to build like a two-level tenant model. And also have a lot of difficult problem not quite well solved. With the hierarchical namespace, I just have just rough idea. And I'm currently doing some investigation. So basically, I'm not sure this is practical or impractical. So I will call that impractical. I will probably get more data or more. I will probably be more clear in a few weeks. So I'd like to have a plan update in next working group meeting.
So just to clarify my thinking again, so is the purpose of this working group is to come up with a list of proposals or suggestions on how we can implement tenancy in Kubernetes, right? And it could be in the form of a CRD, it could be changes to core Kubernetes, but it could be either. But the purpose is just to figure out what's the best way to do it, and then we can take that solution to sig-auth and things like that and say, what do people think, and then come up with something that meets the need and it's not too costly.
Yeah,
Right.
so we have a project plan that is included in Yisui's list of links that you can review to kind of see what our proposal is for how to move tenancy forward. We've broken it down into a couple different milestones that we'd like to achieve and gone over it in a couple other meetings that have all been recorded. So I would definitely encourage you to take a look at that and then ask any questions on the doc.
Cool. Thanks a lot. Yeah. Sorry, I have been wanting this group, but this is my first meeting attending this. So some lot of basic questions.
Yeah,
And these
totally.
are all great topics for either the panel or some of the working group sessions as well as offline discussions. So I would encourage anyone that's attending KubeCon to make a list of these topics and we can brainstorm in person as well.
Right. Last two questions. Sorry. So one, is there a doc that has all the use cases that we are thinking about from different companies or different people?
That is included in the project plan, and so if you have any use cases that are not reflected in there, just make a note and we'll add them.
So which doc is that?
It's this very first link that
Got
Yisui
it.
is highlighting. Yeah.
Okay. Last question is, long back I had created an issue related to how persistent volume should be multi-tenant as well, like they are currently cluster scoped. Is there anybody thinking about how would that work in this multi-tenancy solution if I wanted permissions on persistent volumes, which are right now cluster scoped?
I'd like to, if possible, please just write a doc and share with us if you have any concrete ideas or thoughts. Sure. I have just highlighted very briefly on the this doc about other impacts and list like storage class and volumes.
Right. Okay, I'll reference my issue here and add my thoughts in the comments there. Cool, thanks.
Cool. Yeah. I did want to make sure that we reserve some time for the next presentation that we have up.
So I think I have to stop here. There's not too much time left.
Okay. Faye, did you want to give your presentation?
Yes, please.
Okay, cool.
Should I just share my?
Yeah, that would be perfect.
Can you guys hear this doc?
Yep.
Oh yeah. Okay. So thanks everybody. My name is Fei. I'm coming from Alibaba. So I'd like to take this opportunity to introduce a kind of relatively another angle to solve the multi-tenancy problem, because this is associated very strictly for our Alibaba use case. It won't take long. This is a kind of fairly long talk, but today I'm going to spend about 10 minutes to just go over the introduction. And let's have a deep discussion through the docs or even any channels in the working groups. So,
if you're not seeing your sharing.
Oh. This one? Share? No, doesn't work. Oh, yeah. How about this?
Yep.
Yeah.
Okay. Sorry. All right. So so we come up with proposal kind of tied to our Alibaba use case, because Alibaba we want to share a lot of good things from multi-tenancy. The main purpose is for better class manageability and resource utilization. Where in Alibaba, our talent, which typically an internal BU, has some kind of special requirements. First, they want a hard multi-tenancy model, and they have a special requirement saying that, oh, please don't use namespace to group resource, because many teams has already used namespace to organize individual application. If we introduce a tenant model that has to use namespace, which means many team has to change the way that they deploy their application. which is not preferred. So because of such use case, we propose, we call it virtual cluster-based multi-tenancy solution. So some key factors about the virtual cluster. So basically each tenant owns a dedicated Kubernetes control plane, which we call a tenant master, including the upstream API server, controller, and the etc, etc. But the control plane is not responsible for scheduling. And in this tenant master, the nodes in tenant master are virtual resources, which are backed by the tenant resource provider, which we call a supermaster. So the tenant master and the virtual nodes together form so-called virtual cluster. And the virtual cluster provides a hard multi-tenancy using the sandbox container runtime, like the Kata or gvisor, and just the traditional CNI and CSI plugins. And our virtual cluster solution aims to be a upstream native solution. Basically, there is no modification required on the control plane, the core control plane. And lastly, because we using virtual cluster, we allow the multiple tenants to actually share the same physical nodes with a unified scheduler provided by the supermaster. Then with this architecture, we can achieve kind of high resource utilization for the supermaster. I just compare with, because in this working group, Yisui has mentioned a lot of times by the efforts for the using the namespace to group the resource, present it as a talent, and use the RBAC to provide the isolation. I want to make a few comparisons between the current the approach Yisui mentioned and the approach that we propose. First, I want to mention that these two proposals actually share the same concept, tenant concept. So we both, so basically in virtual cluster, we still treat our tenant is a kind of a group of the resource. With a tenant is a kind of a bounded and isolated amount of compute, storage, networking, and the control plane resource within a Kubernetes cluster. And in the namespace group approach, which is the approach you usually mentioned, the tenants share the same control plane. While in virtual cluster, we provide a dedicated control plane to each tenant, which come at the cost of additional resource for the running the tenant master, like the tenant API server.
Does the dedicated control plane mean dedicated Kubernetes control plane, or it's different?
Dedicated the Kubernetes control plane.
Okay, so separate API server, scheduler, and
exactly.
Okay.
Yeah. So so in namespace group, the tenant resources are organized by namespace. In virtual cluster, tenant resources are presented as a real Kubernetes cluster with full API supports. And the namespace group relies on RBAC to provide API level isolation, but the virtual cluster naturally provides a strong API level isolation because it has its own dedicated control plane. In this approach, there is a common question which is commonly arises because the virtual cluster needs another tenant master, which doesn't come for free. So we agree that this is a very valid concern for case if the tenants only needs small amount of resource and run a few parts, maybe running a full set of the control plane is too costly. Well, indeed, I believe there are some use cases like what we have in Alibaba, where each tenant actually needs to consume a large amount of resource, running a lot of parts. Then the cost of running another control plane is kind of mitigated by the fact of the large amount of the actual workload pods. Another thing is, this is the approach that we're talking about. Having another control plane is a classic kube on kube solution. I think this solution has been used in many places, and we have quite a few ways to actually reduce the cost of the control plane, like share the one etcd or have less replica, etc. So overall, we see this approach is a supplemental solution to the namespace group to deal with different use cases. So next, I will briefly describe the architecture I will skip the details for the readers. If you are interested, you can see the rest of the doc, and we also provide more detailed links for the slides for the presentation if you're interested. So in today's meeting, I'm just quickly go over the high-level architecture. So basically, if you look at this picture, so we have supermaster, which is in the red color, which is actually the resource provider, which manages all the physical resources. Which means in each physical node, the Kubernetes talks to supermaster only. The Kubernetes doesn't talk to any nodes, the tenant master. And the tenant master, from the tenant perspective, they are unmodified Kubernetes control plane, where in which each node is actually we call it virtual node, which is just simply a virtual, which is a API object maps to the VN virtual node agent in each node, not maps to the actual Kubernetes. So the VN agent stands as a proxy to forward all the API calls from the tenant master, which calls the Kubernetes. They forward all the API calls to the Kubernetes and do some manipulation based on the tenant information and do actual Kubernetes call, and return the results for each tenant master accordingly by some manipulator of the results list. And the tenant controller, which is new components, which needs to be taking care of the tenant creation, and also some mechanism to sync all the objects from the tenant master to supermaster. And there is a unified scheduler, which is handle all the pod scheduling. So to avoid all the split brain problem if you have multiple schedulers. So lastly, all the mappings, so all the objects that are created for that tenants and to that tenant mapping is kept, is stores in the tenant object in the supermaster. So I'll give you a simple example. Maybe we can understand this architecture a bit better. Just an example of now with this architecture, although we didn't change the core Kubernetes component, but the many workflow are still affected. Let's see how in this architecture, if your tenant wants to create a pod, now the workflow becomes the tenant first create the pods in the tenant master. Then the sync manager, which stays inside the tenant controller, will copy the pod from the tenant master to supermaster and add tenant prefix to pod name, label, key value, etc. to avoid conflicts. Then the unified scheduler choose a node in the supermaster for the pod. Then the Kubernetes create the pods in the second node, and the sync manager needs to create a node object in the tenant master, which use the nodes as a VM agent runtime info. Then it updates the pod stats back to the tenant master. So basically, in the end, from the tenant perspective, the pods actually runs in a node whose Kubernetes is a VM agent. So yeah, so that is a very high-level workflow change for pod creation.
Okay.
So it is almost time. Go ahead.
So the TB master and the TA master, those are actual Kubernetes API servers, so I can use kubectl to it.
Yes.
Is that correct?
Yes.
Okay.
Yes. That's a dedicated control plane. So you can use all the kubectl to do whatever you think you want. So the only, yeah.
So do you modify the Kubernetes cluster in any way, or you can bring on the fly Kubernetes clusters and they become separate tenants, and then you somehow register these tenants to the supermaster?
No, actually, so if you look at this way, the tenant is actually a pod running another API server. That's it. You don't need to do, so from the supermaster perspective, so definitely you need to register to the tenant controller, because tenant controller need to create roles tenant master. But from the supermaster perspective, it's just a CRD, it's just a pods.
So does the tenant master have scheduler and controller manager?
Tenant master has a controller, but it doesn't have a scheduler. All the pod scheduling is done by the supermaster. So the scheduler is done because, as I said in the workflow, every time if you want to do something, if the tenant want to do something in the tenant master, we have a controller to copy the entire path into the supermaster etcd. Now the supermaster knows you want to do something. And for the scheduling supermaster, we do the scheduler for you using the unified scheduler. So the tenant, so all the scheduling part is hidden from the tenant master perspective. So in the end, as I said, from the tenant master view, they see a nodes, which is a virtual nodes. And the mapping nodes information is not the Kubernetes information, it's a VM agent information. So this is the only thing that we do is we have another abstraction about the nodes. And
how do you add nodes to a tenant in this model?
There is no add node to the tenant in this model. So every time, so this is kind of in this case is from the tenant perspective, you just need to create a path. That's it. So if the path needs to go to different nodes, a new virtual node will be pop up. In the end, it's kind of automatically scaling.
So a node can belong to any tenant. A node can host pods from two different tenants, or nodes are dedicated to a tenant.
Nodes can be shared, can be used by many tenants. If you look at my graph, a node is shared by multiple tenants. So that's a key.
How do you handle cluster wide changes or requests from a tenant?
Tenant has its own API server, right? So any RBAC settings is within the tenant. There is no conflict in the supermaster because we can use, for now, we can simply group all the resources below to the tenant master to a single namespace.
Sure. So I guess, so if I wanted to create a new storage class and deploy, Rookceph or whatever, and it's going to basically have repercussions on all of the worker nodes and basically take up disk on all of the nodes. I guess, how is that handled? And if tenant A and tenant B needed it, there could be potential conflicts on disk usage and
Storage class is the one thing that I want to. I think this is the one thing that we should disallow people to do in this model, because the biggest problem is if the people create some like persistent volume, private persistent volume within this TM master, the unified scheduler is not aware for that. That's a problem. So, but
if we want to. Sorry, this is Yang from Alibaba. So if we want to solve this problem, we need to make the tenant controller aware of all the tenant master resources, so it can copy to the supermaster. So we have the opportunity to avoid the conflict, because at least avoid the naming conflict. But if it is an actual resource conflict, we cannot really avoid it. Otherwise, we need to say, okay, this tenant will have some dedicated nodes, and only those dedicated nodes will have this kind of plugins or whatever.
Gotcha. And I guess just from my pure curiosity, are the virtual nodes, are those actually the virtual kubelet project, or is that separate?
It's separate.
Okay.
Different. Yeah. So but conceptually they are similar, but the VM agent we have is do more than the virtual kubelet.
Gotcha.
Yeah. So this is high level because high level overview of the project. So I welcome any comments. So please just write all your comments in the doc. So we'd like to have further discussion. If you guys are interested, we can use one of the following meeting for further discussion if that is if people want to discuss that. So with that,
Hey, do you mind to share the link in the mailing list or send PR to the links.md file?
I will do that because I just noticed that you have that mentioned, because today you just mentioned that link.pm. I think I need to add this to that.
Thank you.
Yeah. So there are some other problem like network, like service model. I think that is biggest concern by many people, but today I'm going to skip it. So yep. So Tasha, with that I'm done my side.
Okay. Thank you so much. This was a really good overview, and I assume you want to encourage people to kind of read the doc and provide feedback and questions. And then when we have our next meeting on June 4th, we can talk more about it.
Yeah, sure.
Okay, awesome. Thank you so much. Thank you, everybody, and hope to see you at KubeCon EU, and if not, we'll see you June 4th. Bye.